This is a Sudoku I made for International Non-Binary Day. It's based off the Pride flag with its yellow, white, purple, and black stripes. Originally when I made this, it was supposed to be just a fun challenge celebrating a cool group of guys and girls. Or, well, not guys nor girls. Or possibly both at the same time. Anyway, it did not end up being that. Like most of my puzzles, this was much more challenging to create and to solve than I was originally intending. But I did end up finding some pretty cool logic out of it, and I'd like to show that to you now. You can make some pretty quick progress in these two rows at the top if you're familiar with fortress logic, or thermometer logic for that matter. All of these cells have to be greater than all of these cells, so the only place I can put a 1 in this row is here. And likewise, all of these cells have to be less than the cell immediately above them, so the only place for a 9 to go in this row is here. The remaining pairs now, because all the ones on the bottom have to be smaller, once I place an 8, above it has to go a 9. Once I place a 7, above it has to go an 8. And so on and so forth. 6, 7, 5, 6, 4, 5. And so we learn that every single pair in these two rows, the digit above is going to be exactly 1 greater than the digit below. Another way of looking at this is that in these two rows, we know the total sum of all the digits is going to be the same. These 8 cells are greater than these 8 cells, so that's pushing at least 8 into the row above. The only way to balance this is if this digit is 8 greater than this one, and in fact it can only be 8 greater with a 9 and a 1, and that takes away all our degrees of freedom for these pairs, and so they all have to be 1 apart as well. So however you arrive at this conclusion, this is some quick progress. It won't do much to get us into the rest of the grid, and that's where these Ren bands are going to come into play. And there's a couple ways to appreciate the logic here. I'm going to first show you the sort of approachable version, the way I think most people will get into this puzzle, and then I'm going to show you the way I thought about it when I was originally setting this puzzle. The important thing to note is that there are going to be 8 3-cell Ren bands in 3 rows, meaning that these 3 cells are going to be sort of the leftovers of whatever that set looks like. And that causes interesting things, like if I were to put a 1 anywhere on one of these Ren bands, the other 2 cells on that Ren band must immediately be a 2 and a 3. And same thing, if I put a 9 on any of these Ren bands, the other 2 digits immediately have to become an 8 and a 7. Meaning that in this entire group of purple, we're always going to have equal or less 9s than 8s. And the same thing is true of 8s. Anytime I put an 8 in this group, I'm also going to have to put a 7. So there can never be more 8s in this group than there are 7s. There can never be more 9s than 8s. And the same thing with 1s, 2s, and 3s. And that's going to have an implication on these 3 cells. In particular, if I put a 2 in any of these 3 cells, I immediately also force a 1 into one of these 3 cells. And that's because, let's say I put a 2 here. Now the most 2s I can get in purple is 2. But if I put 3 1s here, then I would need 3 Ren bands to go 1, 2, 3. So I can only have at most 2 1s in the purple, and I need a 1 down here. Problem with that is that this line can't have both a 1 and a 2 on it, because they would be in a 1 to 2 ratio. And for a similar logic, I can't have any 3s in these 3 cells, because putting a 3 would force a 2 and a 1 also into this group. So these cells are from 1, 4, 5, 6, 7, 8, 9, and we're just going to start whittling down the candidates. The next important thing to note is this group of cells are all on the same black line, meaning that I can't put both a 1 and a 2 down here. I can't put both a 4 and an 8 down here, and I can't put both a 3 and a 6 down here. So the remaining 3 cells in this box, one of them is going to have to be a 1 or a 2, one of them is going to have to be a 3 or a 6, and one of them is going to have to be a 4 or an 8. So for starters, we know that neither of these two cells are 5, 7, or 9. So they're already down to 1, 4, 6, and 8. This digit now, if I try and make it a 7 or an 8, remember both of those are going to force a 9 into one of these three cells. But the only cell that can take a 9 is this one, so this can't be 7 or 8. And now we're going to brush up against the other interesting property of these Renban lines, is multiples of 3. Each line is going to consist of one multiple of 3, one digit that's one more than a multiple of 3, and one digit that's one less than a multiple of 3. And that means, among other things, if I try and put an 8 in one of these two cells, well, first of all, 8 is going to force a 9 here by the logic we already discussed. But also, now that I've got a 9 here, I can't have another multiple of 3, so I can't have a 6 in one of these two cells. I can't have a 4, because 4 would be in a 1-to-2 ratio with 8. So this would have to be a 1-8 pair. But now, although I can put one of the digits from 3 and 6 here, we're getting 2 and 4 both appearing on this black line, which is no good. So I can't have an 8 in one of these two cells. I also can't have both a 1 and a 4 in these two cells, because 1 and 4 are both 1 more than a multiple of 3. So I need a 6 in these two. That's 6. It's going to do two things. One thing, it means this can't be a 3 or a 6. So this is going to be a 1, 2, 4, or 8. And the other thing it's going to do, once I know these two cells are a multiple of 3 and one more than a multiple of 3, this digit has to be one less than a multiple of 3, and there's only one option for it. This digit has to be a 5. So that's sort of the approachable logic, the way that you can arrive at this digit and these pencil marks down here. But now I want to show you the way that I figured out how to think about this group of 8 Renban lines in 3 rows. And to do that, I'm going to sort the Renban lines in order from lowest to highest. And let's do this with 7 lines. Let's say 7 3-cell Renban lines in 3 rows, and just see what we get. So let's say the lowest one is a 1, 2, 3. And then maybe we have another 1, 2, 3, a 2, 3, 4, a 3, 4, 5, 5, 6, 7, 6, 7, 8, and a 7, 8, 9. And those are our Renban lines. The first thing to note is that the 4th highest and the 1st highest, they cannot contain a common digit. Because as you can see, if they contain a common digit, if these lines both contain a 3, in this instance we're looking at 1, 2, 3, and 3, 4, 5, then these two lines in between them must also contain a 3, and we get 4 3s in 3 rows, which is no good. So in fact we know that this line cannot intersect with this line. These have to be distinct, and exactly the same thing for the 4th highest and the 7th highest Renban lines. These also cannot share a digit. And the same as well for the 2nd highest and the 5th highest, and the 3rd highest and the 6th highest. And the important thing that this means is that we can take these lines in the 1st, 4th, and 7th positions and drag them over into the same column. The only way this works is if we have at least one line that's 1, 2, 3, one line that's 4, 5, 6, and one line that's 7, 8, 9. And we can do the same with the other 2 rows. Now I can grab this line and drag it over here, and this line and drag it over here, because remember, these lines will never overlap with each other. And so you can see that no matter how I dispose the digits over the Renbans in these columns, I'll always be able to sort of fill out a group like this. And if I have 7 lines, 3 of them are always going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. In our puzzle, we've actually got 8 lines, so we get 2 columns like this. We're going to have 2 lines that are 1, 2, 3, 2 lines that are 4, 5, 6, and 2 lines that are 7, 8, 9. And this is the important thing. The remaining 2 lines cannot overlap with each other, and the remaining 3 cells that are not part of Renbans are going to be exactly these 3, meaning that these 3 digits have to be arrangeable in such a way as to fit 2 3-cell renbands around them. We also know that these 3 exterior cells have to contain 2 digits from 1, 2, 3, 6, 4, 8. For instance, you can see if we include a 3, the 2 lines immediately have to go here, and we get a 3, 2, 1, which again puts 2 and 1 both on this black line. So 3 is not allowed, same thing with 2. If I put in a 2, I can't squeeze a renband line down here, so I need to have both 2 and 1, and they both appear on the line. So 3 and 2 are going to appear on a renband. The second renband line in this column is going in one of 4 places, here, 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 or here. If it goes here, then the 3 digits remaining are going to be 7, 8, 9, and they don't include 2 digits from 1, 2, 4, 8, 3, 6. So it's going to at least include a 7. If we went 5, 6, 7, we get the same problem. We're going to have 8 and 9, along with either a 4 or a 1. But 4, 8 repeats on the black line, and 1, 8 forces 2, 4 on the other black line. So that's no good. We have to extend at least up to grab the 8 as well. And now if I try have a 9 in the exterior cells, the only digits it can pair with would be a 1, 5, leaving 2 lines like this, or a 4, 5, leaving 2 lines like this. And either way, we've got 2 digits that are not from 1, 2, 3, 6, 4, 8 on here, so it'll be impossible to fill out box 9. So the only way this line can work is if it goes up to the 9, which means, as we saw in the puzzle, we're guaranteed a 6 in the exterior cells, we're guaranteed a 5 in the exterior cells, and then either a 1 or a 4 to finish it out. So this is basically the same logic, but a more visual way of thinking about it. And this was actually how I constructed the puzzle initially, was I realized this relationship between the 2 remaining red band lines and the exterior digits, meaning that there's only so many possibilities you can have. You can have 1, 2, 3, 1, 2, 6, 1, 2, 9, 1, 5, 9, 1, 5, 6, and a handful of others. But you get the idea. It's actually very restricted once you actually look at the relationships at play. And I was able to figure out what clues would work well to further pare down the options. Jumping back over to the puzzle now, we can start to whittle down these options a little more. In these 2 cells, we've got a 6, so we've got 3 down here, along with either a 1 or a 4. If it's a 1, then we're going to have 2 down here, meaning we can't have 4. 4 is going to have to go up here. And if we have 4 in these 2 cells, then we have 4 trivially. So 4 is always going in one of these 3 cells. That's going to be the digit from 4 and 8 in this group, so this is not an 8. If this is a 1, then it's going 1, 2, 3. If this is a 4, because there's already a 5 in this box, it can't have a 5, so it also has to go 4, 2, 3. And if this is a 2, it may seem like it's able to go 2, 3, 4, but having a 2 here would force this to be a 4, 6 pair, because the 1 would have to go down here. And as soon as I know that this is a 4, 5, 6, in this diagram it means our 3 external cells are 4, 5, 6, so the 2 renband lines are going to be a 1, 2, 3, and a 7, 8, 9. But now all of the other renband lines are 1, 2, 3, 4, 5, 6, 7, 8, 9. So if this is a 2, this would have to be a 1, 3. These digits are always going to have a 3 in them. Now, either this is a 1, 2, 3 with a 4, 5, 6, or this is a 4, 2, 3 with a 1, 5, 6. Either way, these 6 cells comprise the digits 1 through 6. And that means that the remaining renband lines are going to be 3 7, 8, 9s, 2 1, 2, 3s, and 2 4, 5, 6s. And the key thing to note is that currently in this group, we're bottom heavy. We've got a lot of digits on the bottom, and in particular, a lot of digits from 4, 5, 6 on the bottom. And the only way to reconcile this is going to be to put the digits 4, 5, 6 also onto this renband. And I'll give you an idea of what breaks if we try anything else. If I try and make this a 1, 2, 3, now I've got 1, 2, 3 in this row. None of these other Renban lines can be 1, 2, 3, and we simply run out of room to put a 1 in these 3 rows. If I try and make this Renban group 7, 8, 9, irrespective of where I put the second 7, 8, 9 group, we get the same problem, is that none of these remaining cells in the top row can have a 7, 8, 9. In the bottom row, 2 of these cells have to be from 7, 8, 9. So we've got simultaneously only 2 7, 8, 9 Renbans and 4 7, 8, 9 Renbans. So this group has to be a 4, 5, 6. This is not the 5, so the 5 goes up here. These 5s then lock a 5 in this box up onto the white line. Now, because this white line can't have anything consecutive with a 5, it can't have a 4 or 6 up here. So the 4 and 6 in this box are going down in these cells. More importantly, of the Renban lines, we've got 2 of the 4, 5, 6s. Technically, this might be a 1, 5, 6 with a 4 here. But the point is, in these cells, we've got 2 of the 4, 5, 6 groups. We've got 1 more to place, so these 4s and 6s have to appear on the same line. And that's going to put 5 down in one of these 2 cells. That's going to have an impact on this line. This could never be a 1, 2, 3, because we'd have too many 1, 2, 3s in box 6. But now it also can't be a 4, 5, 6 line, so this has to be a 7, 8, 9. 4 and 6 in this box, because of this group and this group, have to go up here. And because of the 5s on this line, they can't go in this cell, so this is actually a 4, 6 pair. This cell now could be a 4 or a 6, but it can't be a 3, 5, or a 7, so it can be a 1, 2, 4, 6, 8, or 9, but it can't be a 9 because there's a 9 in the row. And the digit above it has to be 1 more than it, so it could go 1, 2, 2, 3. This can't be a 4 because it would make this a 5, but it could go 6, 7, or 8, 9. Looking at this box now, the digits 1, 2, and 3 all have to appear in these cells. But importantly, all of these cells see this one, these 2 in the column, and these 2 via the Renban. So this can't be a 1 or a 2. This has to be our 4. And that's going to resolve that this is a 1, 6 pair. And down here, we're going to get the counterparts 2, 8, and 3, making this line valid. This is a 4, so this now has to be a 2, 3 pair. 1 is going in one of these 2 cells in the box. And now I'm going to swing on over and have a look at this line, which has an interesting impact on the box, now that it can no longer be 4, 5, or 6. If I were to make all of these 3 cells 1, 2, 3, or 7, 8, 9, that would make 2 consecutive pairs on this line, actually. So I have to make this either a 1, 2, 3 with a 7 and a 9, or a 7, 8, 9 with a 1 and a 3. Those are the only 2 options, but we have either 2 low digits and 1 high, or 2 high digits and 1 low along this stretch, meaning that these 2 lines are of different dispositions. I'll just color one purple and one green to illustrate that. One of those is a 1, 2, 3. One of them is a 7, 8, 9. So we've identified 2 of the 7, 8, 9s, 2 of the 1, 2, 3s, and 2 of the 4, 5, 6s. These 3 lines are going to be 1, 4, 5, 6, 1, 1, 2, 3, and 1, 7, 8, 9. Key thing to notice now is that along these lines, because one of them has to be a 1, 2, 3, where can the 1 go on it? It can't go here because of the 1 in box 2, and it can't go in either of these 2 because we've already got the 1 in the row down here. So actually we get the 1 appearing in box 4 in one of these 3 cells, and that's going to force the 1 in this row onto this white line. Once I get a 1 on this white line, it can't have a 2 on it, so the 2 gets forced onto this white line. Once I have a 2 on this white line, I can't have a 3 on this line, so the 3 has to go over here. And more importantly, I can only have 1 digit from 1, 2, 3 in this group, so I need 2 digits from 7, 8, 9. It has to be the 7 and the 9 to avoid having a consecutive pair. These 3 digits are going to be 1, 3, and 8, and the 1 and the 3 have to appear on the same line. So this is a 1, 3, this is an 8, this is a 7, 9 pair, and we know the order. This is a 2, I can remove the colors now. Now we can ask which one of these 3 lines can be a 7, 8, 9. Can't be this one, because this cell cannot be 7, 8, or 9. And it also can't be this one, because every single cell along this line sees this digit, which, even if we didn't know it was a 7, would eliminate itself from this entire line. So the only line left that can be 7, 8, 9 is this one. I can remove 7s from here, 8s from here, 9s from here. And actually, once I get a 7, 8 pair here, both of these digits see this cell. One normally and one via the Renban. So this can't be a 7. This is our 9, 8, 7, 8, 7, 9. And we finish those. And now we just have left to figure out which of these is the 5, along with a 4, 6. And which of these is going to be a 3, along with a 1, 2. This can't be a 1, so this would have to be the 1. And that's going to cause problems, because if I put 1, 2, 3 along this Renban line, then this cell, which has to be a 1 or a 3, has no value. So this is not the 1, 2, 3 line. This is the 4, 5, 6 line. This is the 1, 2, 3 line. The 1s in this box now force 1 on this line to go over here. And the remaining digits up here are going to be a 3, 5, and an 8. This can't be the 8. Now that we've done about all we can on the Renban side of things, it's perhaps time to focus on these consecutive pairs up here and the remaining white lines. This one in particular looks quite powerful on this digit. It can't be consecutive to a 2, and it can't be a 2, so 1, 2, and 3 are out. Can't be consecutive to a 7 or a 9, and it can't be a 9, so 6, 8, and 9 are out, so the remaining options are 4, 5, and 7, making this either 5, 6, or 8. If I tried to make this either 4, 5, or 5, 6, we immediately get too many 4, 5, 6s in the column, so this has to be a 7 actually. This has to be an 8. And now we can ask where 8 goes along this row. Can't go in any of these cells because it would be consecutive to 9 on a white line. Can't go in either of these cells by Sudoku. And if I tried to put an 8 here, I would have to put a 9 above it, and that clashes in the column. So this is our 8. This is our 9. And now that's going to have an interesting consequence on these white lines, ignoring the 9 for now, because there's no digit that can anymore be consecutive with it. So we effectively have 2 3-cell white lines that have to contain the digits 1, 2, 3, 4, 5, 6 in some order, and none of them can be consecutive on a line. So there's a couple ways to see this, but I think perhaps the easiest one is whichever line I put 2 on can no longer have 1 or 3. It needs 2 digits from 4, 5, and 6. Can't have a 5 because that would be consecutive to both the other options, so it'd have to be 4 and 6. And similarly, whichever line I put a 5 on can't have 4 or 6, so it needs 2 digits from 1, 2, and 3, and they have to be 1 and 3. So these 2 lines are going to be split between the even digits and the odd digits in this group. So now let's just start pencil marking some options. This column is looking particularly restricted. We can have 2 with 3. 4 is no good, so we can have 5 with 6, and 7 and 8 block all the other possibilities. This cell, 1 with 2 looks fine. Can't be 2 with 3, because that would kill both options for this cell. 3 with 4, 4 with 5, 5 with 6, and 6 with 7 all look okay. Actually, this can't be a 5, because then there would be a 2-5 pair, and we would have 1 even and 1 odd digit, so 5, 6 is gone. This cell also can't be a 2 or a 5 because of this, so this can be 1, 3, 4, or 6. It actually can't be 1 because there's a 1 in the box. So we're looking at either 3, 4, 4, 5, or 6, 7 here. For this one, 2, 3, 4, 5, and 6 all look basically possible, except a 6 here would put a 7 here, and that would clash in the column. So this can't be a 7, that can't be a 6. And now the tricky step, the most difficult thing to realize here, is what happens if I try and make this a 3-4 pair. It has a huge impact on the candidates here, because it knocks the middle options out. This can no longer be a 2, so this would have to be a 5-6. But now these two digits are both odd, and we've already established all the odd digits are going on the same white line. So actually, this cannot be a 3-4 pair, and the only remaining candidates, 4 and 6, are both even. So this line is going to be the even one. This is going to be a 2. This is going to be a 4 or a 6 with a 5 or a 7. This has to be a 3. And now this is going to be the odd line. So 3 or 5 with 4 or 6. This can be 1 or 3 with 2 or 4. And this can be 1, 3, or 5 with 2, 4, or 6. I could have done this earlier, and this would have helped a little bit with the logic up here to notice that there are 6s in both these columns. But I just now spotted it because there's a 4-6 pair in this column. So this has to be a 1, this has to be a 6, 6, 4, 4, 6, resolves the 7 and the 5 above there. That 6 also is going to make this a 4, 3, 1, 5, 6, and 2. And we've finished all of these pairs. And now we get some nice triples remaining in the boxes here. This is going to be a 1, 6, 7. This is the only place for a 6, 1, 7. In this box, we've got 2, 5, and 8. Doesn't seem to be resolved just yet, except I know this isn't an 8. In this box, I've got 3, 4, and 9. This digit is now a 9, so we can actually place the 9 up here, leaving behind 3 and 4. This 1 is going to give us a 3, 1, 1, 2, 2, and 3. This 2 looks up and makes that no longer a 2. This 3 means that's no longer a 3. This 3 means that's no longer a 3, so we get the 3. This 2 is going to resolve our 2, 7 in this box. This 4 resolves our 4, 6. That's going to place 6 in this box, leaving behind a 4 and a 5. That's resolved by this 5, so we get 5, 4, 4, 3. And now it looks like it's just going to be the black lines left to resolve all of this. Right off the bat, we've got a 4, 6 pair along this line. So this digit cannot be an 8, or else it would be in a 1-to-2 ratio with the 4. So we get 7 and 8 here. That's going to resolve our 8 and our 2 here. 2 in this box, going into one of these two cells. Would be fine along this line. This line we don't yet know about, but it's looking risky with the 1s and the 4s. In fact, this cell can't be a 1 or a 4. So if I did put 2 along this line, then 1 and 4 in this box would both have to go here, which is impossible. So this is the 2. That's going to resolve our 5, 8, 2 up top. That resolves our 8 and our 5. 5, 6 down here. Let's keep going. We haven't used the 7 yet. So 3, 7 go in. 3 and 1. 1 in this box is now placed, leaving behind just a 4 and a 9, which we can do. It's going to resolve our 9 and our 5 and our 6 and our 4, and we've finished the puzzle. So yeah, tricky break-in to start, but not as tricky as it could have been. I do think it would be cool to make a Renban puzzle with this idea. This sort of where you have to figure out that the remaining digits in this group have to dodge 2 Renban lines. But I'm not too dissatisfied that you can sort of finagle your way around it, because it is still quite tricky, and you do still have to appreciate a lot of things about this line, like for instance that it has to have 1 digit from each of the 3 groups modulo 3. And the rest of the solve I was pretty pleased with as well, how some interesting logic actually did emerge with these simple rule set ideas. Originally I was thinking this whole section would just end up being a non-consecutive mess, because no one likes non-consecutive, let's be real. But I did like this sort of trick with separating the evens and the odds up here and distinguishing them using the options in box 2. So yeah, pleasantly surprised how this puzzle turned out, despite being just a sort of experiment based on a theme. And happy non-binary day.